So can anyone summarize the previous classes? President, can you summarize the NCL class? What did you learn? Samuel, what did you learn? From the beginning to last. This is the last class, right? So,
it would be better if you summarize it.
okay, so
Yeah, so many things. Even from opening to doing some tasks with NCL is time.
like in NCL, we learn about the data analysis, right? How to open Netcdf file, or text file, or CSV file, etc., right? And how to see the variable name, and how to see the time, lat, long, etc., different dimensions. What is the data type, and how to convert the data, right? Even some functions used to analyze your data, right? Then we learn how to plot. Yeah, so different issues, right? And we learn how to plot different figures. Even in the last classes, we learn how to handle the shape file. You have the Netcdf file, you want to mask your data by a shape file, then you want to plot, right? So that was the summary. Like we learn now, if you have the NCL code, you'll find the thousands of NCL code in the online, right? In the NCL website. So now you'll understand the code. Okay? In summary, in NCL, there is 3 parts, right? First part is data analysis, right? Then the second part is just what type of figures or plot do you want to draw, right? It can be PNG, PDF, or EPS, whatever. Then we have the resources, right? Who can tell me what is the importance of the resources in NCL? What is the importance of resources in NCL?
The NCL resources, like graphing resources,
Huh?
like map.
Not only math, resources is the heart of NCL. If you want to modify your figure, if you want to customize your figure, whatever, you have finished your analysis, now you want to visualize your analysis, right? Visualize your results, then you need to use the resources. Clear?
Yes.
Then, finally, the plotting. Clear? Now, tonight, I will talk about the output. Like, now you know how to analyze, now you know how to plot, but the problem is like you have the Netcdf file. Maybe you want to extract your data as in like in CSV file or text file, right? How to do that? So, tonight we have the data 80.nc. So, we know how to see the data and variables, right? What is the command in NCL? To see your variables, NCL file them, right? NCL underscore file them. Then our data is 80, then tab.nc. So these are files. Before you analyze your data, you need to know your variable, right? You need to know your data, know your data, know your data before you do anything. In any softwares, any languages, you need to know your data before you do anything. Clear? So, we'll learn our variables. So it's 4 dimensions. We have the time, we have lat, long, and level, right? Then we have different variable. We have the surface pressure, temperature, then reference height, temperature. Then we have the zonal wind, meridian, etc., etc. So From there, we want to extract our variable. Like you can extract the whole variable. It's up to you. Just I will show how to extract. Then you can extract more than, like, maybe you have the 10 variables. It's fine. You can 10, 100, whatever you have. You just follow the script, follow the code. You just use, right? For this class, we will extract 3 variables. One is t. So we know our variable name is capital T. Okay? This is the temperature, the unit is Kelvin. And we have the 4 dimensions. Then we have the Jalal wind. This is the capital U. Then we have the meridional wind component is B. Should be in WeChat. Did you have the GIF file? Did you receive the GIF file? In IMSA, WeChat. There is no file?
Here's the code.
Only the code, no file. Only this will be sent to them. Oh, sorry. I just said that.
Oh. Is there? You see, I made this a zip file, but I sent only the code. I thought I was sent this zip file. Okay, now we have the data, right? at.nc. Just download. So we want to extract 3 variables. One is temperature, zonal wind, and meridional wind, right? And we have 4 dimensions. We have time, the level, lat, and lon. Okay? Now, we have the 4 dimension. First we will do, we'll convert the n dimensional to 1 dimensional. This is the function, n dimensional to 1 dimensional first. Then we'll conform in 4 dimensional. And then we'll convert 1 dimension again so we can write them to CSV file. So this one first, we have the 4 dimension, then we'll do n dimensional to 1 dimension. Then we'll conform the dimensions. So the first one, the dims means the dimensions. The NCL use dimension sizes. Like in MATLAB we use size. we can see the shape of the file. In Python, we use shape. It's the same thing. Okay? So dim sizes. So our first dimension is time, right? That's why we want to extract the t time to 0. We want to confirm this dimension. Then our first dimension is what? Time. Then second dimension is level. Third dimension is lat. Fourth dimension is lon. Okay? This all the one dimension. We had the 4 dimensions. We made n dimension to 1 dimension. Then we confirm with the time, level, lat, lon. Okay, let's open the CSV file. Then you will understand the code. So this is our data. We want to get our data with time, level, lat, lon, right? With value. So you want to give the header the name from your file. You have time, you have lat, you have lon, right? This is a CSV file. You need to write from the Netcdf file. You will get this output when you run the code. But for understanding, so we need the header, right? Like our variable is temperature, right? In Kelvin. Then wind is meter per second. That's why the code is saying we want to give the headers. Did you get it? So that's why we want to create an array. For the array, we use the parentheses, then backslash. The first header, we want to give the long name, the temperature, time, long name, then time, level, lat, lon, then we have the units. Look at the CSV file. We want to get the time, long name, then we want to get the lat, lon, our variable with unit. Right? So we need to write them. So we use this and. Maybe if you miss the last classes, it will go with your 500 above your head. Here. So this is the time, the level, lat, lon, units. Then we want to join them. This is our all string. You already know what is the string. So we want to add them as header. Then you can give the file name. Any name you can give there. Then we need to remove. If we have this file, we're not sure, but if you have the existing file, you need to remove. Here, so this is a system rm remove the CSV file name. If you have this file already, it will remove, it will give you the new file. Here. Then we need to write table. CSV file, or this is our ASCII file. You know the ASCII. What is the ASCII? ASCII and binary. NC file is a binary file. So you can see by, this is not the human readable, right? ASCII file is human readable. So CSV is ASCII file. So you need to write something. In every language, you need to write. So you need to write the table. This is the CSV file. This is like a table. Here, you need to write. But you need to access the data, the information from the NC file. Then, the function has 4 arguments. One is your file name, NC to CSV file. Then we want to write. W means write. R means read. Clear? Then with header. Then the percentage means you already know if you want to write something, this is the format to write. S means you want to write as a string. If the F, this is a floating, you want to write floating data. If it is D, that means you want to write the data as a double. These are format in every MATLAB, Python, whatever, anywhere. It's like you need to use this percentage, then you need to format. Okay? Now, our T, U, and B was a 4 dimension. So for writing in CSV file, we need to make it 1 dimension. You see, everything is 1 dimension. Temperature, wind is 1 dimension. But our data was 4 dimension together, right? It's the NC file. So we need to make it 1 dimension. Then we can keep 1 dimension, like with time, lat, long, or variables. Okay? Now we want to make the list. For the list, we use the square bracket. The same way as Python. We want to make a list. So first we have the time, label, lat, long, then our variables. Then we need to write them is a format. What is the Z? Z is C language. So NCL, in the first class I said NCL is mixed of Fortran and C. So NCL use C program to print float or double. That's why NCL uses G. Like our data is floating. I think you already learned from the first class in the data science. What is the float, short, double, etc., etc. So the data is floating. So we are going to write this value. So what is the format? The float or double. So NCL use %Z like C. Then we want to write the table, CSV file name, then you want to append. If you use W, it means you want to overwrite. But you know what is the append? Do you know the append? Do you know the append? Do you know the concatenation? So you want to add them. Clear? You have the 3 variables. Every variable has 4 dimensions. You just extract a 1 dimension, but you want to add them together. And you want to make the one file, one table, right? Like you have 10 variables, but in one sheet, one CSV file, right? You want to add them together. Clear? So you need to append. You want to add them. Clear? Then which list? We already created the list. Then which format do you want to write? We want to write our data as floating. Here, %Z. You can run now. You should get this file. So if you don't have the programming language, it's a bit difficult to understand. The same way like sprintf or sprinti, everything is the similar. Every language you want to write something. So next time if you want to extract your data from Netcdf file to CSV file, you can use this code, and then you can draw a temporal figure anywhere, maybe in Excel, in MATLAB, Python, whatever. But even you can plot the temporal figures in NCL, right? That's up to you. Maybe you want to do more statistical analysis, so it's better to extract the data from there and you go other software. It's up to you, okay? Okay, now let's see the NCL page. So what we will do if you need something from NCL. So now you know the basics of NCL. You know how to analyze your data, how to plot your data, right? How to use the function, etc., etc. Now, if you want to analyze something, so there is thousands of code in NCL. That is the power of NCL. You don't need to write the code. So you just change your data, and you know the basic. So say for example, if you want to analyze the anomalies, with figure there is a code with explanation. So you don't need to write this code, just open this code, and there is a description of this code. So you already know the basic, you just need to change something with your data. That's it. All are the same. Like if you are using the model, it's fine, different models there. Like if you are a WAF user, go there. And there is code for WAF model and the function. So you don't need to write the code. You have the basic now, you just use this code and analyze. And you know NCL can open Netcdf, HDF, GRIF, Netcdf4, etc., etc. NCL is powerful. Any data can open. ASCII data, CSV file, notepad, etc., etc. So there is a code. Now you have the basics. You go there. And even from the first class, you know, we have the NCL talk group, right? It's a big platform. Then you can subscribe and you can post if you have any question. So this is the last finish. Do you have any question? But NCL is now going to Python, transfer to Python. It has the Python code. Every language is going to Python. Python is easy, powerful. Yeah, easy. Why easy? Like in NCL, C4 and MATLAB, you can't write one line once. Like if for you need to finish the end, and there is option you need to comma, etc. Python is one line. You can use a loop, a condition, etc. Tuple, list, whatever, string, every code. But in NCL, C, MATLAB, no. If the data is string. Then there is a float. If the data is missed, no. So in Python, you can use the one line. It's finished. You can use different type of data is together. That's.
You have videos in Python?
Yeah, that's right. So NCL also going to Python. Okay, thank you so much.